here's what it looks like when we're starting to make truth tables. So we have a proposition, let it be P, and it could be any proposition that you wish, which is a statement that can be true or false. It can be true or it can be false. It cannot be both, not in the same way, for the same person, at the same time. You can add these disclaimers, but in general, it's either true or false, not both, not either. And then we start wondering, okay, what else can we know from that information? Well, remember that the tilde is that squiggly sign for us, and tilde represents a negation. It's not the case that, or the concept of no, or rejecting the idea. So here we're rejecting P, and here we're stating P without a hedge or a disclaimer. So if I said P, the proposition that abortion is immoral, if it's true, if P is true, then not P is false. It is necessary to say that somebody's claim that it's not true that abortion is bad is false if we were to find out that the claim about abortion being immoral is true. But we can do it the other way. So if we learned that P, which stands for the proposition that abortion is morally permissible, is true, then we have necessarily, logically speaking, objectively speaking, scientifically speaking, absolutely discovered that it is not the case that abortion is permissible is false. So your statement, tilde P, in other words, it's not the case that abortion is permissible, is false if the statement P, abortion is permissible, is true. Now, adding the double negation to kind of complicate this slightly further, you might have noticed that the tilde P always gives you the same truth values as P. Because in semantics, there are, even in symbolic logic, the rules where you can drop the double negation. So if I said, it's not true that it's not the case that abortion is immoral, that's the same thing as saying abortion is immoral, because I said not. So it's like saying, I don't not like you. In other words, I like you. If it's true that I like you, then it's true that it's not the case that I don't like you. These will always have the same truth values going down the line. If it's false that I like you, then it's false that it's not the case that I don't like you. Because the two negations, you can eliminate them. It's like saying this pen is not orange, or this pen is orange. So these truth values will always match. These truth values will always be different. To say P and not P, or to say not P and not P, will always be different. Because if it's true in one world, then it is necessarily false that the opposite is true. We're going to go from considering just one proposition P and its negation to considering two propositions and its truth table for a conjunction. Remember that symbol that almost looks like an A to stand for and with the missing line represents conjunction, the act of putting two variables together, propositions. When we had just one proposition, P, we have two lines because each proposition can be either true or false. Since we just have one idea, we have two rows. One row for if P is true and one row for if P is false. But with a conjunction, if we're trying to figure out if P and Q is true or false, we have two variables. And if we had P and Q, they could both be true. one could be true and the other could be false, where P is the one that's true, or one can be true and one is false where Q is true, or they can both be false. When P is true and when Q is true, P and Q is true. But if P is true and Q is false, then you can't have a conjunction that's true if one of the pieces is true. Necessarily, P and Q is going to be false. Likewise, if you had Q being true and P false, well, you're trying to put two things together. They're not both true, and so the conjunction of them together as a proposition will not be true. It is necessarily false. And if P and Q are both false, then putting them together through the act of conjuncting, you're not going to get a true proposition either. So you need both P and Q to be true in order for your statement P and Q to be true. Because P can be either true or false, every proposition can be either true or false. When we're just doing the truth table for P, or tilde P, or tilde tilde P, or tilde 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 P, any truth table we're making for one proposition will always have two rows, because there's only and always two possibilities for the truth value for P. It's either true or false, so you get two rows. On the other hand, since we have two propositions here, P and Q, and each one can be true or false, you have four rows, because they need to take turns so that you really did list every single possibility that you can have. Now, in a different argument, you might want to make a truth table and list every possibility. If there are three propositions, then you will have 8 lines, because each proposition can be true or false. So that's true or false times true or false times true or false. You can do the math by putting how many propositions you have as the exponent on the number 2, and then you know that you get true or false raised to the exponent number of propositions you have. So for example, if you had 5 letters, then that would be 2 to the 5th power of rows for your truth tables, and that would give you 32 lines on your truth table.